Hi everyone, this is part 2 of WhatsApp lead management bot, and in this part I will be walking you through the complete backend code. So the backend I have written in Fast API and it is connected to a LangGraph workflow, and an LLM is also integrated there. So this we will deploy in some cloud service, and then from there the WhatsApp service will interact with this backend API. Okay, so first step, let's go through the flow that I've created on LangGraph. First, I will show the diagram of the flow, how it looks like. So the flow, it will look like this. So at the start of the conversation only, it will try to see what is the current state of the conversation. So by default, the current state, like when the first message, the current state will always be intent, and as and when the as the conversation goes, it will change to requirement and handover. I will tell you at which step it will change. Okay, so when the first message comes, it will go to this the current state will be always be intent, and it will try to classify the intent of the user. In terms of classification, what it will check is that based on the message, whether the user has any FAQs that should be answered, or whether the user has already provided the requirements which should be collected, or whether the user is just providing a hi hello message that should be greeted, or whether it is something else which is not part of these three categories, or the final state whether it is a handover answer. Okay, in handover, basically here the bot is simply asking, do you want to connect to a real estate agent or a human? That is when this state will be like executed, and it will give the message. So I will try to walk you through this, and then I will tell you at which step the state changes. So starting with this, so classify intent. Let's say the user has asked me a general question about property management, because this bot is around a real estate management, a real estate agency. So if it is a general question, it will go here. It will answer that question from this bot. So this is a LLM call, by the way, and then whatever answer is generated, it will be returned to the user. Here the state will not change, it will remain intent, or it will be a default state basically. If it is gather requirements, then what it will do is that basically this will be classified as gather requirements only when the user has given some intent already in terms of what they're looking for, whether they're looking for flat commercial space and what is a budget and all. Then it will go here and it will check the requirements, and then it will see whether whatever questions needs to be answered. So in our bot, the question that we want answers for is that whether they are looking for a flat commercial space and other, or and what is the budget, and which location they are looking for. If all these three questions are answered, then it will go here and it will search properties. Here we have just hard coded the options that are available. It will get those, it will present the results to the user, and here the state will change to handover, because the options are already shown to the user. Now we have to ask the user whether you want to talk to the agent or not. Okay, if the any of these three questions are not asked, then it will go to missing requirements side, and it will end here. Here in this side only the state will remain to requirement, which means that the next input from the user will also go through this flow, and it will check whether all the requirements that the bot wants are answered or not. So it will keep going in this flow until all the questions are answered. Okay, so now this is done. This handle greeting means that if the first question from the user is hi, my name is blah blah, or hello, hi, how are you, then it will go here and it will simply this will also be an LLM call where it will simply give an introductory message in form of a greeting and tell that what this bot is all about and what it can do. Okay, then other is something which something if the intent doesn't fall in any of these categories, then it will go to other and it will try to only answer related to property, and it will say I don't know for any other question. Let's say, for example, if the user wants to just play around with the bot and says that okay, what is the capital of Karnataka, then this bot should not be answering that, although it is powered by LLM and LLM knows the answer. But we will send it to other, and to others we have given strict instructions that do not answer any question which are not related to real estate. Okay, so this is the flow. And yeah, I think I've explained every component of it. Now let's go to the code side of it. So this is the LangGraph agent definition. So I will go through each and every component. These are all the required imports. Here we have initiated our LLM. Again, I'm using the Grok API. This is a state of the graph. The state will be messages. Here we have used add messages uh, reducer, which is most optimized for LLM messages, which have human message, AI message, system message. So this is optimized for that, and then it will keep adding all the message in this field. Okay. Then here is the intent. What is the intent of the user will be stored here. Then requirements, it will be a dictionary, and it will be dictionary of those three values, and then it will check whether all three are collected. If not, then it will go in an infinite loop. Then properties, so this will be just hard coded, and during the run of the flow, it will just add a fixed list to this field, and so that the final state can be returned. Then current step, what is the current step that is going on? So I think current step means this. So current step means this: intent, requirement, or handover. That is the current step. So whether when the message comes, whether we should go in this, or directly here. Okay. So this is the fields. Now this is a router where we check what is the current step. So current step, if we get a value from the state, uh, what is the current step, then that will be assigned. Otherwise, it will always be none. Okay. In case of none, it will always go to this one, which I will show you later. Okay. If it is gather requirements, then it should go to return requirement, as you can see here. If it is handover question, then it should go to handover. And in all other cases, it should go to intent. Basically, in case of none also, it will go to intent. So next is the classify intent node. So here I think I should have given some spaces to make it easy to read. So this one needs this class, what is the intent, and intent is a just a class of these values, a dictionary of these values, by property, this is a value, FAQ, greeting, other. So these are the four possible intents of the user, right? FAQ, uh, by property means this one. It will go to gather requirements. Then greeting, it will come here. Then other, it will come here. Here, this one will never come as a intent. It will be changed to handover only after this step. Okay, this is not really an intent of the user. So that's why you can see that it is not connected to classify intent. Intents are only these three: one, two, three, and rather four. Okay, four intents, as you can see here also, right? So now we have created a structured LLM with this Pydantic class, so that the output always comes in this form. Now this is the node classify intent. So we will take the last message from the state messages. Okay. So in the main.py file, I will show you how all the messages are collected and sent in the initial state. Then this is system prompt. It is simply saying your intent classification assistant. You must classify the user intent in exactly one of by property, FAQ, greeting, or other. So far it is working fine. But if you think that, okay, this is not classifying correctly, then we will have to provide some examples and provide an extensive prompt. But for me, this much was working fine. Then we get the structured response. We invoke it with the system message, and the last message, basically in the messages, all the conversations are stored, and the last message of that messages list is the user's current input, which has come to the bot, and this will go as human message in this form. User message is this. Then whatever is the output, it will be a structured output, so it will have this value intent. We have to get the value of that, and lower, we just to safeguard, we are converting it into lower. So then it will tell you what is the intent, and it will send the complete state. In the state we have added the intent, and we are sending the complete state to the output. Okay. Next is requirement output. Okay, this is the class. Here also I will add some spaces. So yeah, this is the gather requirement node, which needs this class in the LLM. So we have created another structured LLM for gather, which takes this class. Here we are asking for three fields: budget, location, and property type. These are all string fields and they are optional. Okay. So if the user has not provided, it will be none. Now in this node, what will happen again? The last message, last input from the user. Then in the prompt, you are simply asking you are a requirement extraction assistant, extract the following information: budget, location, property type. If any of the above information is not present in the user message, return it as null, JSON null, not as a string null. So I think I added this line because it was getting confused and it was sometimes providing a string also, and then it is not considered a null. Okay, so if it simply says in like this, null, then it will consider that okay, this location was already provided by user, which is not correct. So that's why I have provided this strict instruction. Always just return structured output following the schema strictly. So the schema we have already provided. This may I might have to write because I'm using an open source LLM free of cost. But if we use something from OpenAI or Azure OpenAI, then chances are that it will give better output. So now we are simply calling this by sending the system message and the user input. The requirements are, so if uh, okay, so if the requirements are already in the state, which means that if in one of the previous messages the requirements are already gathered to some extent, then those requirements will be our starting point. Then we get these three values. So these three values will be, first preference will be given to field list budget if it is present, otherwise it is none, else if it is present in the requirements. Okay, means that in the previous message it is already extracted and it is saved in the requirements in the state. Okay, otherwise it in all other cases it will be none. Same for location, same for property type. First preference given to the current output, then next preference given to the state, the previous state, and otherwise in all other cases it will be none. So here we will send this dictionary in the requirements field, and we will return only this field in this output. Then is a check requirements. So here check requirements node. So after gather requirements, it will check whether all the requirements are uh, completed or not completed. So what it will do, it will check that okay, if it is requirements are not in the state, then we will just initialize it, because chances are that in some cases it might not save it properly. So we have, just to avoid error, we are saving it, initializing it as a blank dictionary, and in that case nothing is available and all the fields will go in the missing. But in other cases, if the budget is already present in the requirements, or if it is present in a state requirement budget. Oh, or this is none. State requirement is none. Okay, so what it is saying is that if budget is not in this state requirements, or in the state requirement budget is none. So sometimes what happens is that it saves it. This field is present in the requirements this dictionary, but it is saved as none. So in that case, also it might, this might consider it as present, but we have to check both the conditions, that if it is not present, then also it is null. And if it is present and it is none, then not also it is not present. So basically the missing messages we will save. If budget is not available, it will add this message, what is your budget? If location is not available, it will add this message, that location you are looking for. Then if property type is also not available, then, so basically if any of these three are not present, then accordingly the messages will be added. Okay, if all three are missing, then all three messages will be added to the this, and it will be sent to the user to give an output around that. Okay, so here if you see, the current step has changed to gather requirements, which means that after intent we have gathered requirements, we are checking it, and we are going here. So here we are not, right now we are not going it, but if at this level, if it is going at this stage, missing requirement, then the next step also start from requirement only. It should not start from intent, because then in that case it will erase all the previous inputs we have already collected from the user. So until all the requirements are completed, then it should go as an infinite loop. And this is a very unique way of using human in the loop, and it works pretty well. We don't have to save the complete checkpoints and all. Uh, so because that saves a lot of information, and it is very restricted also, in my opinion. This is purely in our control. We can change it and we can modify it the way we want. Okay. So now, okay. So if missing, then uh, the current step in the state will be gather requirement. If not, then the current state will be reset. Okay, by default. Yeah. So now search properties. So after if okay, so this is a node, but we will connect it to through a conditional router, which I will show you to search properties. But right now, what search properties will do, it will simply return these two options, which are hard coded right now, but we can connect it to a database. We can do some search, we can do vector search, whatever search we want to do. We can add all that logic here, and then we can return the results based on the input from the user. Okay. Now then, present results. So this node, present results, it will simply just give a text message. Okay. This is not an LLM call. It will simply, whatever messages we have, it will say here are some options, and then we have name, location, price. We have it here. And then it will formulate a message. It will get send this in the messages field, and it will append it. And then current step will change to handover. So after this step, only the current state will change to handover. Okay. Otherwise, it will remain in this state requirement. Now, next is handle greeting. So handle greeting is another node, if you can see here. So if the intent is change, uh, chosen as handle by the LLM, then it will come here. It will simply say answer this greeting message politely as a real estate agency, and this is a message from the user. So let's say for example, if the user says only hi, then it will reply accordingly. If the user says hi, my name is this, then it will reply using that name also. Okay, and simply it will be saved as an AI message in the messages field, rather added. Okay, and then we can send that state. Or we could simply send messages is equal to this also, and then it will be added automatically. We did not have to explicitly add. So that also will work. Now handle FAQ, handle FAQ node. Here also we are simply just asking that, okay, just try to answer only about real estate. If the FAQ is unrelated to real estate, don't answer it. Instead, let me show this in this form. Guide the user to ask only real estate questions. Okay. Keep all answers short, accurate, and customer friendly. Then again, I'm sending this prompt and the user's message, and then again I'm appending it to messages and sending it in the state. Handle other. So if the category is none of the above, then it goes to other. And here, this is a prompt. We are simply asking you are a polite and professional assistant for a real estate agency. The user's message has already been classified as unrelated to real estate. Do not attempt to answer their question. Instead, generate a short, courteous response that politely declines and guides them to ask only this. So basically, here we are just trying to be more uh, uh, so that the LLM creates a response new every time, rather than giving us the same kind of response every time. We can simply send a fixed answer also. I'm sorry, I cannot answer this question, but that might not look very pleasant to the user. So we want LLM to be polite and be courteous and generate a different message every time, so that the experience is a little better. Okay. So now again, we are adding the output here in the messages, and we are sending the state. Now handover answer. In case of handover, what it will do, already asked this, generate a short and final closing response based on the user's reply. If oh yeah, so basically in the final response, in after this step, the bot will always be asking whether you want to connect with the uh, a real estate agent or a human. So if the user says yes to that or agrees to that, then confirm the handover politely and let them know a sales agent will reach out. If they say no, or they give an unclear response. Like if you remember in part one, I showed you that as an output, I just mentioned my name is Jatin. So that was also unclear response. That will also be considered as a no. So then politely acknowledge and close the conversation, telling them they can return anytime for property related queries. Do not ask follow-up questions. Always end the conversation politely and professionally. So now here also we are sending a prompt, user's last message. We are adding into the message and the current step will be changed to none, which means after this step, after this handover answer, it will always go, the next message will always go to this step. It will never go to this or this step. So this is very important. And the requirements have also been reset. We have reset the requirements because now after this, the new requirements will come from the user. Now route from classify. So classify, we have a route like if the intent is buy property, then go to gather requirements node. If intent is FAQ, then go to handle FAQ node. If greeting, then go to there. In all other cases, go to handle other. Okay. Route from gather. If you can see here, where is the gather part? Yeah, here. So route from gather, it will take the requirements. If any of these values is none, uh, no, if all the values are captured, then go to search. If any of the values are missing, then go to missing, then return missing requirements basically as an output of this. So based on these values return, it will decide whether to go to connect to end or whether to connect this one to search properties. Okay. Now we will simply compile. We will create all the nodes, all the conditional edges and edges. So these are all the nodes that I have already described. This is the conditional edge starting from classify intent, and this is the conditional router. And based on these values, these will be the nodes that will be connected. Okay. So as you can see here, classify intent, based on the output, it will decide which node to connect to. Okay. So this was a redundant step and it was not required because as you can see, the names are exactly the same. And for that reason only, you don't see anything here also, right? Nothing is present in these three steps. But if you change these names in this router, then these names will start showing at this place like this. And then uh, this step will make sense. Otherwise, this dictionary is not mandatory. We don't have to send if the output coming from the router is the node name itself. Okay. Now we simply create a straight edge between gather requirements and check requirements. There is no conditional router here. Another conditional router from check requirements, this one, missing requirement and search. So here as you can see, we have a different node name. So that's why search is mapped to search properties and missing requirements is mapped to end. So these are different, which are not coming as an output. So that's why these names you see here. Okay, this is another thing. Then we simply add two more edges from search property to present results, from present result to end, and from handle FAQ also will be connected to end, handle greeting also will be connected to end, handover answer will also be connected to end. And finally, we will add a conditional edge from start to these three nodes based on the output of check step conditional router. Okay, if the output is requirement, as you can see here, requirement, it will be connected to gather requirements. If it is handover, then it will be connected to this node. In case of intent, it will be connected to classify intent. Okay, now we just simply compile the graph and this is done. So I added some new lines, so that's why I had to save it. So now let's go to the main.py where we have the backend API. So here all the necessary imports. Okay. So here optionally you can just save the graph as in the form of an image. So I always do it at least once because so that I can visualize that how my graph is looking like and whether it is making sense or not. Then I initialize the fast API. Here, these two functions will simply convert because the output of structured LLM output is not really a dictionary or a JSON. It is a class object which has these kind of objects, human message, AI message. So those we cannot save it as it is in the database. Okay. For that reason, we have used a serialize where it will take the class output and it will convert that into a JSON or a dictionary or a Python dictionary. Okay. Yeah. And here deserialize because when we are getting all the messages from the database and sending it again to the bot, then we want to send again as a class object which has these classes, human message, AI message. So that's why we are deserializing. While sending it as initial state, we deserialize and send it. Okay. So now this is the DB file. I'm simply using an SQLite database for demonstration purpose. It will be a local file created here when I run it. I deleted it some time ago so that we can create a fresh one. So this will be the file name which will be created. Then initdb is just to initialize the database if it is not already there. If you can see here, create table if not exists. Okay, if it already exists, then this will not do anything. Then save state. So when the output comes from the bot, then every time the state will be saved to the database against that number. So if you can see here, conversation state, session ID. So where is it getting called? Yeah, from number. So from number will be coming from the WhatsApp API, and based on that number, because number is always unique for a user. Based on that number only, we will save the state separately for each user. Okay, so save state method is here. So it will save into the database. Get state will be when we want to send an initial state, we will simply run this and get the state uh, of the user, like all the conversation history. Along with that, we will also save the current state so that we can decide that whether which route they want to go to, the bot wants to go to. So this is for that. Then this is simply to a get method to invoke the bot. So what is happening here is that I have deployed it in a free service, free cloud service. The only challenge with that is that it sleeps after 30 minutes of idle time. So to wake it up, I have to just simply run the URL that is provided by that cloud service, and it will call this method and it will simply wake it up, and after that only I can talk to my WhatsApp bot. Otherwise, it will not respond because the uh, API is in sleep. Okay. So now this is the real API where the WhatsApp API will send a request, and this is how it is working. I will quickly walk you through. So this is just a method name. It does not matter what name we give it. The form, basically whatever form is coming from the request. And this is just to troubleshoot and like check whether it is working fine. So whatever coming from the form, it is the input coming from the WhatsApp number. Then from number, it is in the form we get the from field from which okay, so basically this will be the complete dictionary. So whatever is coming from, it will be saved in the form. And in that form, the from field will give the number from which the message is coming. And in the body, it will show the message that is coming from the user. Now we will run the get state to get the current state from the database. We will use this from number. And in the get state, if you see, if the conversation does not exist, it will simply return none if row does not exist. Okay. Yeah. So get state, or if it is none, then it will be an empty dictionary, our initial state. Okay. If messages is not in the state, then messages will be added as a empty list. Okay. Then yeah, in that empty list, we will just current message from the user, we will append as a human message in this one and send it to the bot. Okay. So that, because if you see in the LangGraph agent file, every time we are just picking the last field, last entry from the messages list as a input from the user. So we always send it in this form. So this will work in all the cases, whether we have a long conversation history, in that case also it will work. If it is a first message, that case also it will work. Now this is the final state. coming from the bot. So now we initialized the app graph already. Now we are invoking it with our current state. In the current state, we are simply sending whatever state we got, and we are adding the current message also, and we are sending it as a state. So yeah, so this will be the final output. Now, once the final output is coming from the user, we save this state again uh, with this as the index as a key from number, and this will the final state will be which will be saved. And these are the messages. If messages, then the last message is this. If it's a lang chain message object, then if it is as a reply text, let me just see what it is doing. It's a dictionary reply text. Okay, so basically, what we have to do here is that we got the output from the bot, but we have to send that output or the final message to the WhatsApp API also. So here the messaging response from so here we are using Twilio for as a WhatsApp API. So we have to send this reply text also. So the last message from the saved in the messages will be the output, which will be the AI message, right? So that we will send. If this does not exist, then we will simply just to save from getting an error, we have saved it like this, but mostly it will always return an output. Okay, and then we return the final response like this. Okay. Yeah, so this is the backend API. Now let me try to run this, and we can test it in our local also in form of a using a Python notebook. I will show you. Let me just run this first. Yeah, so it is running. So now if you see, once this app ran, this state.db was initialized and it was created. So hi, my name is Jatin. So this is the message that I will be sending, and the number I'm sending is just a dummy message, dummy number, and let's see what output we get from here. Okay, so see, hello Jatin, welcome to our real estate agency. Pleasure to meet you. How can I assist you? So this will be the output that will come from the API, backend API. So yeah, so this is all from for this video. This is the backend API code that I've explained. In the next video, I will try to explain how to deploy it in a free cloud service so that we can connect it to the WhatsApp API, which we will be setting up in Twilio. So thank you for watching this video. Please uh, look for all the other videos in this series so that you can have a complete understanding of how this bot works and how it can be deployed end to end. Thank you. Bye.